Hello, this is Chuck Ridgway, Automation Technology Manager at Horner. Thanks for joining us for another Tuesday live stream. Well, I'm back from vacation and I think we've got a good topic today. Here it is. BACnet MSTP networking for building automation. Now, communications and networking type videos are always the most popular on this channel, maybe besides the videos where we preview what's coming in the upcoming months from a new product standpoint. But from a communications standpoint, BACnet is also one of the more popular communications topics. And I think the reason is because there's always a lot to learn about communications, and I think there's a lot of interest in BACnet these days. And we've had a few videos on BACnet, as you might expect, but we've really never focused in on BACnet MSTP. So that's what we're going to do today. Now, if you're watching this live, you can go ahead and give us your comments and questions in the chat section, and we'll get those answered right away. If you're watching this on replay, we'll get your questions answered from the comment section within a day or two usually. All right, let's take a look at how we break down today's topic. Okay, we're going to dive into what is BACnet for those of you where that's a new topic for you. We're going to talk about what does a BACnet system look like? How does BACnet work? And then we're really going to focus in on BACnet MSTP, which is a specific version of BACnet, a specific, installation network, if you will. And we're going to talk again about the installation as well as the settings. And then at the end, we're going to talk about using the Horner Micro OCS all-in-one controller on a BACnet MSTP network because it's a really good fit. For one, it's a low-cost controller, and a lot of times, BACnet MSTP installations are looking at costs very carefully. It's another reason we're covering it this week is because it's a relatively new feature for the Micro OCS, as the Micro OCS has only supported MSTP for a few weeks or a few months now. Okay, so that's how we're breaking down the topic. Let's just go ahead and dive right in. Okay, so what is BACnet? BACnet stands for Building Automation and Control Network. Now, just like the industrial space, in building automation, back in the day, there were lots and lots of proprietary networks going on from all kinds of different manufacturers, Johnson Controls, Landis and Stafa, all kinds of company names, some that are still around, some that aren't. And like an industry, what happened is there was a lot of standardization that started and standardized networks have emerged. And in building automation, really, BACnet has emerged as the primary building automation and control network for newer installations. Definitely, it's the most popular these days for sure. Okay, so when you're looking at a BACnet system, typically what you're talking about is building management systems, where you've got a building management system that is overseeing and coordinating all kinds of different devices in a building environment. Maybe it's a single building, maybe it's a campus or a series of buildings. But BACnet systems can get rather large, and you can be talking about systems such as lighting systems and HVAC type systems, and also, systems like air compressors that might be used for manufacturing or even chillers in some cases. So there's literally hundreds of different devices that could be, connected on a BACnet type system. Okay, now BACnet, as we dive into the protocol just a little bit today, we won't get down into the weeds, but BACnet as a protocol, it follows the standard OSI model, but it kind of collapses the 7 layers down to 4. And it also defines multiple options for the media that you might use for your network. And what we mean by that are, you might be running your network wirelessly, you might be running it on Ethernet, you might be running it on RS-485, RS-232, all sorts of other options. But by far, the most popular options these days for BACnet is BACnet over Ethernet or BACnet IP, which we've covered many times in this channel, as well as BACnet MSTP, which is the RS-485 version of BACnet, which we're really focusing on today. And you can see there's other options as well, but again, those two are the most popular. Now, what does a BACnet system look like? Well, it's very common for there to be a mix and match of BACnet MSTP as well as BACnet over Ethernet or BACnet IP. You could have a whole bunch of these different separate networks that are all interconnected so that on a building management level, maybe at a campus level, there can be literally thousands and thousands of devices that are all literally tied on the same system. And it can be a combination of devices that are sitting directly on a BACnet over Ethernet network connected to standard Ethernet switches and routers. It can be multiple BACnet MSTP networks over RS-485, where each of those individual networks is connected through a router, which routes the data back and forth between RS-485 and BACnet IP. And you can very often also have legacy systems, maybe an older proprietary building automation network from Johnson Controls or something that's connected through a gateway to BACnet IP, so the building management system can see that information as well. Or it could even be a Modbus network. And in that scenario, you could use a Horner OCS as a gateway, because we talk Modbus about as well as anybody does. And of course, we also talk BACnet IP. So lots of ways to get different types of devices all interconnected and back to the building management system. Now today, again, we're really going to be focused on BACnet MSTP, the RS-485 version. And specifically at the end, we're going to talk about how you can use the Micro OCS product from Horner in that environment. Okay, but before we dive into the details on MSTP, where we talk a lot about the physical installation and the setup and the settings and those sorts of things, let's dive in a little bit more into BACnet from a protocol standpoint. And let's start with some key definitions. So let's start with what is a BACnet device, what are BACnet objects, and what are BACnet properties. Well, the BACnet device is represented by that kind of bluish purple box you see on the screen there. And a BACnet device consists of multiple BACnet objects. And those BACnet objects are, they contain BACnet properties. Okay, so that's really what you're talking about. A BACnet object is, or I'm sorry, a BACnet device is a collection of BACnet objects, and a BACnet object has a series of parameters or properties that it supports. Okay, now when you're talking about BACnet devices and their collection of objects, what types of objects are used within a BACnet device? Well, the BACnet specification, the last time I looked at least, there were 54 different types of objects that could be used in a BACnet device. And of course, in a lot of cases, you're going to use multiple instances of a particular object type in a BACnet device. For instance, let's say that you're doing temperature control and your machine or your equipment is going to be connected over BACnet. And you may have a few different temperatures that you're monitoring that you want to share on the BACnet network. So those would all potentially be considered analog input objects, each of those individual temperatures. So your particular BACnet device might have half a dozen different analog input type objects, different instances of the analog input type object included with that particular BACnet device. So really, BACnet devices are a collection of objects, maybe of different types, often multiple instances of the same type. Okay, now let's talk about BACnet services. What's that? Well, that defines how devices communicate. And just like there's lots of predefined types of objects, there's lots of predefined types of services, although they are kind of divided into different classes. And there's 5 different classes you can see there on the slide that kind of categorizes the different services. Now, the communications with BACnet typically follows the client-server model, where a client is a device on the network that sends out a service request, and a server is another device on the network that replies with a service response. So definitely BACnet is designed around a client-server model. Next, let's talk about something called a BACnet device profile. What's that? Well, that defines the expected capabilities for devices that are similar to each other to ensure interoperability. So effectively, they've defined what we have on the screen. There are 8 different device profiles, kind of listed from most complex down to most simple, if you will. And the one I've highlighted there is called an application-specific controller. That's the device profile that's highlighted. And that is the type of device that the Horner OCS is when it's included on your machine and your machine is talking over BACnet. It's an application-specific controller. And that makes sense because if you think of the way a general-purpose product like a PLC or a Horner OCS works, they can do a lot of different things. You might be using it for lighting control or temperature control or to control a chiller, whatever the case may be. Again, that sounds application-specific to me. Okay, so that's the type of device that our OCS happens to be. It follows the device profile of application-specific controller. Next, when we're talking about interoperability on BACnet, we need to talk about interoperability areas. And there's 5 different ways, if you will, that devices will interact with each other. And again, they're shown there on the screen, from data sharing down through trending and device and network management. And there's something else that's defined that's called a BIB, or a BACnet interoperability building block. That's a lot to say there. And that's shown there on the right. That's kind of a nomenclature that shows, the interoperability area, the service that's used, as well as the function in terms of whether a device is a user or is a client or a server, for instance. And so by following that nomenclature, I think the next table will make it a little more clear why it's valuable. It allows you to see what each device profile, or what each type of device that fits within a specific device profile, it kind of defines the expectations for that device. So if you look across the top, or the column headers, if you will, on this chart, those are the different device profiles, the 8 different device profiles that are available in BACnet. And if you look down the rows, if you will, along the side in column A, those are the different interoperability areas. And then each individual cell is showing you the different bibs that should be available for each of those different types of device profile type devices. So in the case of the Horner application-specific controller, you can see there are 5 different bibs in 2 different interoperability areas that are expected to be available there, and those define the services that should be available so that you can ensure that communication does occur between devices. So if we're going to summarize kind of some of these things on BACnet, that first chart you see there on the left talks about a collection of objects that happen to be available in the Horner controller when it's being used as a application-specific controller. Okay, that second and third chart shows the individual parameters and properties that are available for the device object, which is required among all BACnet devices, as well as the analog input object, which is often used with a Horner controller if you've got a temperature or something else that you need to share with the system. And then on the far right there is the list of services that are supported by the Horner controller specifically. So again, these are the different areas within the BACnet protocol that help assure consistency as well as interoperability. Okay, now let's dive back into the specifics and get really into the specifics on BACnet MSTP. Remember, that's really the focus of our topic today, but to really get here effectively, we need to do a bit of a review of BACnet in general. All right, so let's dive into BACnet MSTP, makes it unique, and some of the specifics that you need to know for that particular variant. Okay, so MSTP, first of all, stands for Master Slave Token Passing. That's what those digits stand for. Always got to have an acronym, right? And as I mentioned previously, MSTP utilizes RS-485 type communications for the physical network for exchanging BACnet data. Now, RS-485 is 2-wire, at least BACnet uses the 2-wire variant, and it's half duplex, which means that only one device can transmit at a time over RS-485. So over MSTP, only one device can transmit at a time. So how do you decide who gets to transmit when? Well, the devices are going to take turns communicating and transmitting based on a token. So whatever device has the token, that device gets to transmit at that point. And then when it's done transmitting, then it passes the token on to the next device. Okay, so now let's talk about the physical installation of BACnet MSTP. Now, there isn't a whole lot to talk about with the physical installation of BACnet IP, or BACnet over Ethernet, because it's pretty much standard Ethernet wiring and standard Ethernet switches and all those sorts of things. However, BACnet MSTP, because it is a physical network that's not just, Ethernet cabling, there is a little bit more to know, and so I wanted to review that with you today. Okay. So you should use with BACnet MSTP shielded twisted pair wiring, somewhere between 18 and 24 gauge. And your capacitance of the cabling should be less than 30 picofarads just to ensure reliability. Now, in terms of the pinout or how you wire it, it's really pretty straightforward. Now, you typically should use it as a daisy chain. You should wire it as a daisy chain. So you've got two conductors to deal with, a plus and a minus. So you should connect the pluses to each other all the way down the line, plus to plus to plus to plus. Same thing with the minuses, minus to minus to minus to minus. Now, we also specify, or BACnet specifies, shielded wiring, so you need to handle the shield properly as well. So the shields should really only connect to each other, right? So every place there's a break in the shield because you've got a device that's been mounted there on the network as part of the daisy chain. At all those points, the shields should only be connected to each other. And then effectively what you're doing is you're creating one continuous shield. At one point in that created continuous shield, you should earth the shield, again, at one point only, and that'll provide an appropriate way of shunting any noise and keeping it away from the transmission signals. Now, of course, RS-45, as a lot of you know, does require termination at the physical ends, so you need a 120 ohm resistor at each physical end of the network, and that resistor should be mounted across the plus and minus terminals at the beginning, and then the plus and minus terminals at the end. So that's where you need the termination, 120 ohms. Now, there's also something called biasing that I think a lot of people don't understand as well. What biasing is pull up and pull down resistors that should be mounted at one place on the network only, okay, that basically take spurious voltage signals that might be floating around, and they basically get those out of the way. They either pull them down to ground or pull them up to V+, so they aren't misinterpreted and become spurious ones and zeros that can screw up communications. Now, typically, the biasing is handled by the MSTP router that links the MSTP network with the rest of the building management system, typically over BACnet MS. I'm sorry, over BACnet IP. So generally, that's where the biasing is performed, is at the router level at that particular physical device. Now, the OCS does have the capability of doing biasing. You can enable that if you wish, but the reality is biasing should be handled at one location only, and that's typically done at the router when it comes to BACnet. Okay, now let's talk about some key settings that are important to know for BACnet MSTP, starting with what is called a MAC address. Now, in the Ethernet world, a MAC address is a unique address that's assigned by the manufacturer of the equipment. Completely forget about that. That's not what we're talking about here. Okay, with BACnet MSTP, the MAC address is really what was called the network address with other networks like Modbus and DeviceNet and those sorts of things. So it's the ID on the local network only for that particular device. In the case of BACnet, legal addresses are 0 to 255, but most devices that sit on the BACnet network are technically masters because they handle the token, and so most devices on the BACnet network are going to be in the range of 0 to 127. And again, that's just the address for the device on the local address, on the local network only. So there on the right, I'm showing 3 devices on a simple MSTP network. One is the router that's linking over to BACnet IP, and then 2 MSTP devices hanging off that router. And you can see we've assigned MAC addresses of 0, 1, and 2 in that particular case. Okay, now the next important setting is the device ID. This one is more global in scope. So remember, let's think of a BACnet installation maybe at a college campus where we literally might have thousands and thousands and thousands of devices, all more or less on the same system. We might have dozens or even hundreds of separate MSTP networks. And whereas on any individual network, we're going to have MAC addresses between 0 and 127 for any master type devices. If we're talking about an entire system now, we need to make sure that we can identify each individual device on the entire system with a unique number. And that's where the device ID comes in, which can be a number anywhere ranging from 0 to 4,194,302. So the device ID is the one that needs to be unique in a facility, and that facility could be an entire college campus, for instance, whereas the MAC address, again, just needs to be unique on that local MSTP network. Okay, and then the other thing, of course, you need to set up properly is you need to make sure on any individual MSTP network that all the devices have the same baud rate, parity, data bits, and stop bits, whatever those happen to be. I believe the default is 38,400, no parity, 8 data bits, and 1 stop bits. I think those are typically used as the default for BACnet, but of course, double check me on that. Okay, now we mentioned the fact that with RS-485 half duplex, only one device can transmit at a time, and it only transmits when it has the token. So how does that token passing scheme work? Well, effectively, the token is passed from device to device in the order of the MAC address, 0, 1, 2, 3, etc. Okay, which means that when you're setting up your system, it's important for your MSTP MAC addresses to be consecutive. All right, you don't want any big gaps in there in the addresses. Otherwise, it'll cause delays as one device attempts to send the token on to the next address on the list. If I'm device number 3 and I'm done with the token, I need to send it to, I mixed my metaphors here. If I'm MAC address number 3 and I need to send it on to the next device, that would be MAC address number 4. Well, if there is no MAC address number 4 and the next one happens to be MAC address 52, there's going to be a long delay while I attempt to send the token on to the next MAC address. So you want them to be consecutive. That's important. And there's also a parameter you can set called max master. So that's a parameter that can be set in any device on the network that each device checks before it sends on the token. So again, if I've got a MAC address, let's say of 3, and I'm done with the token, I'm going to send it off to MAC address number 4, unless I check the max master setting and I see that the max master setting is equal to my MAC address. That means I'm the highest numbered device on the network, which means I need to pass the token back down to MAC address 0. So that's what the max master setting does for you. Okay, for the last few slides here, we're going to talk specifically about using the Horner OCS all-in-one controller to put your machine on a BACnet network. So if you're making chillers or you're making big air compressors, or you've got some sort of heating and cooling system that you're selling into big facilities, you might be using a Horner OCS controller to control your apparatus or control your machine. And you've got the ability now to put that machine on the local BACnet network because it's available in the OCS. So let's start by talking about which specific OCS controllers support BACnet. And really, this applies to both BACnet MSTP as well as BACnet over Ethernet or BACnet IP. So first of all the Prime series and all the XL series from the XL4 on up, as well as the X5, those products all have it built in and standard from the factory. So if you're using those devices, your controller just has BACnet, both IP and MSTP built in. Now, if you're using the micro OCS, because it's nice and cost effective and it controls your machine well, BACnet is an option. You know, that's part of the price of having a lower cost unit, is that not everything is included. So with that series, there's a couple different ways of getting BACnet support. Let's talk about those next. First of all, if you want to use BACnet MSTP with the micro OCS, you're going to need to make sure you are using either the X4, the X7, or the X10. Now, I previously mentioned the X5. It has it built in. Okay, so that's also supported. But if you're using an X4, X7, and X10, you just need to make sure you have Seascape 9.9 Service Pack 11 or later, which has been out for a while, firmware 15.78 or later, which has been out for a while, and you either need to order a unit from the factory with BACnet already pre-licensed, which is a part number extension of -444, or you can, if you've already got your unit in hand, you can purchase a BACnet license voucher with the part number shown on the screen there at the bottom. and you can upgrade your unit in the field. It's just a one-time charge, no subscription or anything, to add BACnet capability to the unit. And in all of these cases, when you add BACnet capability, you're adding both BACnet IP, which is Ethernet, and BACnet MSTP, which is the RS-45 variant we've been talking about today. Okay, now let's go through a few slides quickly showing configuration, and then we'll do a live configuration for you. Okay, since BACnet MSTP is a serial-based network on RS-45, you're going to go to Hardware Configuration, and under Serial Ports, you're going to hit the Config button. And then when the next dialog pops up for the serial ports, you're going to see the pull-down list under MJ2, which is the RS-485 port, and you're going to select BACnet MSTP from that list of things that also includes Modbus, for instance. Okay, and then there's really 3 levels of configuration you need to do on BACnet MSTP. The first level is the network level. The main things to configure there are the baud rate, parity, data bits, and stop bits. You need to make sure those match your existing MSTP network, okay? And once you've done that, you also have an opportunity, it's not shown there in the snapshot, but you also have an opportunity to assign a status register, a main BACnet status register that you can use for troubleshooting purposes. We'll go through the details of what that data is available from those status registers a little bit later, but I would definitely encourage you to take advantage of status. Now, the next level of MSTP configuration is the device level. Okay, so this is where you can assign a helpful name for documentation purposes to your device. I think it can be up to 12 characters long. And this is where you assign the BACnet ID. Remember, the BACnet ID is the one that can be up to 4 million or so in scope. It's a 22-bit value that has to be unique across your entire facility. So that's where you configure that. And then there's another opportunity to assign some more status variables for some additional troubleshooting information as well. And again, we'll cover that detail here in a few minutes. Okay, and then the final level of configuration is effectively to opt in to which of the BACnet objects you want to use in your application. Now, in the case of the Horner OCS, you can choose to use analog values, analog inputs, analog outputs, digital values, digital inputs, or digital outputs. The only difference between a value, an input, or an output is whether it's read, write, or read and write. So in the case of an input, it's basically an input only. In the case of an output, it's an output only. In the case of a value, it can be read or written, okay? So you get the ability to choose which of those types you want to support, and you can support all of them or just one of them, depending on your desire. And in the case of analog values, which I would encourage you to support, you can also select the data type between integer, double integer, real, whatever the case may be. And for each of those different object types, you can also select how many of each of those you want to support. So maybe you're doing temperature control in your machine and you want that machine to be sitting on BACnet, and maybe you've got 3 temperatures that you want to share as analog inputs in integer form. So in that case, if that's all the analog input data you had, you could assign a predefined variable array to the analog input type with a length of 3, for instance. Okay, let's go ahead now and just demonstrate what I just talked about, how to configure BACnet MSTP on a micro OCS. All right. Okay, so again, we start in the hardware configuration area under serial ports and config. All right, on the drop-down list for MJ2, we're going to select BACnet MSTP server from the list, and then we'll just go down and configure 3 different areas, starting with the network. Here's where we set our baud rate, parity, data bits, and stop bits. The rest of this is really kind of immaterial. We don't really need to worry about any of the update scan or any of those sorts of things. Down here, we have 2 things we can configure. I definitely recommend you take advantage of BACnet status. We'll go into the details on what that entails here in a minute, but you just need to assign a variable array of the double integer type with a length of 8 or a dimension of 8 here with this particular status for the main BACnet status. And then you also, if you choose, can assign a bit type variable where you can actually disable BACnet capability and then re-enable it by turning that bit on and then off again. That would really kind of be used as a virtual BACnet reset, I guess, if you will. That would be kind of the functionality for that if you wanted to take advantage of that. Okay, so that's configuration on the network level. On the device level, this is where we configure, we assign a convenient name, we assign that ID that has to be unique across our entire BACnet universe, you know, up through 4 million there. So if you've got a college campus, you have to use a lot of care here, of course, because you might have a lot of different devices. And then you have additional status that you can take advantage of. In this case, 3 words. Again, we'll go into more details later. Now, this is something that throws a lot of people off. Don't get intimidated. There's this other button right here, configure device options. Okay. Oh my gosh, look at all these parameters. How are we ever going to get all these set right? Well, there's good news. There's really only 2 that you really need to worry about in 99.9% of your installations. And that is the MAC address, which is the network ID for the local network only. Okay, so for the local MSTP network, that has to be between 0 and 127 because the OCS is considered a master from the standpoint of that it handles a token. Okay, I've set it to 3 in my example. All right, so remember, you want these to be consecutive and you don't want any gaps. Now, if the OCS was the highest number on the network, the highest MAC address on the network, then we would also want to set our max master to a 3 as well, but only if the OCS is the highest ID MAC address, at least on the network. If it's not, you can just go ahead and leave it at 127, which is the default. Okay, so really this looks intimidating, but there's not that much to it. Okay, so once we've done that, then we've configured both on the network level and the device level. The last level is the scan list. Okay, and the scan list looks like this when you configure it. Now it starts out blank, and then you just fill in the details. So what I have done here is I have chosen to take advantage of strictly analog values and digital values. So these are data words, or in this case, floating point values that can be read or written over the network. These are Boolean values that can be read or written over the network. And I have chosen 4 real type analog values and 4 Boolean type digital values. Now, because these values ultimately, these variables ultimately are going out over the network in a separate step, we really need to map these to specific memory addresses in the OCS. For analog values, we're going to map those to %Rs. For digital values, we're going to map those to %Ms. Okay, M as in Mary. All right, so where do we do that? Well, we do that in the program variable window. So let's go there now. We're done configuring BACnet MSTP. Now we can go down to our program variable window, and here is the variable array for my analog values in the real type with a dimension of 4. So we've got indexes from 0 to 3. Here's my variable for the digital values, again, with a dimension of 4, index from 0 to 3. And I need to map these to real-world locations. I chose to map the analog values to %R 101 through 108. Why through 108? Well, remember, these are floating point values. They take 2 16-bit memory addresses each. So that's 101 and 102, 103 and 104, 105 and 106, 107 and 108. Okay. Now in the Booleans, of course, I happened to choose M97. I didn't have to choose this address. I could have chosen just about any address. I chose this because it's on a word boundary. Remember, word boundaries are like address 1, 17, 33, 49, etc. So M97 is on a word boundary. That makes it a good choice. And it's a type M type, which also makes it a good choice. And I'm only using 4 bits here. So that's M97, 98, 99, and 100. Okay, so I've got those arrays for my analog values and my digital values, and they're mapped to real-world locations. the last thing I have to do is for every variable that ultimately is going to end up going out over BACnet, I need to map that variable in those ranges as well. So as an example, I have an oven set point, all right, that I want to be available as one of the analog values over BACnet. So I need to assign it in the range of R101 through R107. Remember, R107 is the fourth of those 32-bit values. So I've done that for the oven set point. It's mapped to R101. I also have an oven temperature at R103, a gas valve percent at R105, and a conveyor speed at R107. So those are those individual variables are now mapped over to BACnet. Now, one other thing I want to mention, and that is that from the building management side, okay, from the building management software, what they will see at the other end for each of these variables is the actual memory address itself. So for the oven set point, they'll actually see that identified as %R101. For the oven temperature, they'll see that identified as %R103, et cetera, et cetera. So we aren't currently allowing the variable name itself to be sent over the network. That might be an enhancement we do one of these days. Okay, and then finally, we've got 2 of the 4 digital values that we have allocated. We've got 2 of those defined. We've got a burner bit and a conveyor bit mapped to M97 and M98 respectively. And M99 and M100, which were pre-allocated in the array, haven't been assigned yet. Okay, so that effectively is configuration of BACnet MSTP. All right, now let's head back, and I've got a little bit more information I want to share with you before we wrap up. Okay, let's take a look at some of the real-time status information that's available to you if you take advantage of status like I encourage you to. So in the main BACnet MSTP status, that's 8 double words, okay? That table on the screen there shows the information that's available to you. All right, now, the one that's probably the ones that are the most interesting are probably the good frame count, okay? That one you should see increment periodically to tell you that you've got good communications going on. And then if you get an error code, and the arrow's kind of pointing in the wrong spot there, but if you get the last error code is also interesting. If you get a non-zero value in the last error code section of the status feedback, then you know you've got a problem, and there are 4 different error codes that you could receive. And by decoding that, you can see specifically what your problem is, whether you've got no error, which is a 0, or one of 4 different actual errors, which is shown on the table. Okay, so that's the main MSTP status feedback. You also can take advantage of the device status feedback, and that's just 3 different elements to that, 1 double integer and a couple of integers. Again, you've got another good count area that you can hopefully see increment periodically as communication occurs. And then you can also see what your local MAC address is for the OCS node through the status feedback, as well as the MAC address for the device that last requested information from the OCS. So that's also available in the MSTP status, again, available at runtime. Okay, so that wraps up what I wanted to cover. Oh, actually, we have one more thing I wanted to show you, and that is this. For those of you that have a micro OCS in hand and you'd like to license it for MSTP, it's a very modest cost. I think we're talking $50 or $100, so it doesn't cost a whole lot to add that capability to your existing unit. Or, of course, if you don't have a unit in hand, you can order one from the factory with a -444 part number extension, again, for a very modest increase. And keep in mind, the alternative to that is an expensive gateway component, which you would have to purchase, or a more expensive controller maybe to get you one that includes BACnet as standard, but maybe it does way more than you need, and otherwise the micro OCS is a perfect fit. Okay, so I've got a short video, just a couple minutes here, that shows you how to take your existing micro OCS after you've done the firmware update, and assuming you have Cscape 9.9 Service Pack 11, that allows you to take that and go ahead and license it in the field for BACnet MSTP. Okay, I'm ready to license my unit here that I have, my micro OCS unit, for BACnet. And it doesn't matter whether I'm licensing it for BACnet IP or BACnet MSTP, one license handles both. Okay, so what I've already done is I've already purchased the voucher, and I've received an email that contains the voucher number, and I've copied that so it's in my clipboard. So let's go ahead and start the licensing process. So I have established a connection with my controller. Now, I just had previously updated the firmware in the controller, so it's just sitting there in idle mode. But I've got a connection with it. And I have a micro SD card installed in the unit because that is required at least for the licensing process. So that's where I'm at right now. So I'm going to go to the hardware configuration area, and then under serial port, since I'm going to be using BACnet MSTP, I have selected BACnet MSTP on the MJ2 port. That's the RS485 port. And you'll notice we've got a button here called Display and Validate. So I'll press that button. And it says no BACnet license has been issued to this connected device. And it lists the MAC address, which is the internal Ethernet MAC address for the unit. Kind of a unique identifier, if you will. So, okay, it's not yet been licensed, but I expected that. I'll hit OK. I'll hit Obtain License, that button here, and this is where I will paste in the voucher code that I purchased and received via email. So I'll hit the Paste button. Okay, it tells me that this license is valid, and it has one license currently available under that number, so that's great. I can hit Apply Voucher. Okay, tells me the voucher code was applied successfully. So I just need to power cycle the unit and the licensing will be complete. So that's really all there is to licensing a micro OCS unit, either X4, X7, or X10 for BACnet, whether you're talking about BACnet IP or BACnet MSTP. One license takes care of both of them. Okay, let's button this up by validating on the unit that the unit has been licensed for BACnet. So I'm going to go to the System menu. I press the upper right-hand corner, then the System button. The last menu item is License Details. And the last item on the list on this screen is BACnet License. And you can see the status is yes. So this unit has indeed been licensed for BACnet as we expected. Okay, so that wraps up our program for today. This is where I remind you we're here every Tuesday, whether we're fully live like today or whether we're fully pre-recorded like last week when I was on vacation. If you're watching live, there's always somebody standing by to answer your questions from the chat section. But if you watch on replay, we'll also answer your questions and comments from the comment section. Okay, don't forget to sign up for training. These are the training classes we've announced for 2024 thus far. I'm sure there will be more ultimately, but don't wait too long to sign up for training. Now, you have a lot of ways to interact with Horner Automation online, whether it's on our website, whether it's on our YouTube channel, or whether it's on LinkedIn, because we're very active on LinkedIn. Now, because I was on vacation, I didn't complete all the prep that's required to get all the different topics announced for today's webinar or today's live stream. So that's my fault, but you can look on our website at the normal location. And sometime in the next couple of days, it'll announce what all the April webinars or live streams really are going to be, again, for the month of April. Okay, so if you haven't subscribed to our channel, don't hesitate to do so. It doesn't cost anything. And if you choose notifications when you subscribe, you'll be notified every time we go live or every time we post a new video. All right. So I better get working on getting those topics sent to Marcy so she can get those on the website. Until next week, let's all get out there and let's do us some good.